So, starting to feel reasonable. The whole circuit is almost like the inductor wasn't there.
For inductor.
Now, how would I get the total current? I total equals?
V total over Z total.
C e to the I phi or A plus IB?
C e to the I phi.
C e to the I phi. Now, is this equation in peak or RMS?
Yeah.
Now, what voltage were we given? RMS. What is the first thing we are asked for? Peak. So if I wish to do this equation in peak for now, what am I going to put in for the voltage of the power supply?
10 root 2.
10 times square root of 2. Because I've decided to use the equation as peak. I was given RMS, and I know how to get peak from RMS. I multiply by square root of 2. And the phase of the power supply shall be?
E to the I 0.
Yep, 0 as always. We put in the impedance with 5,000.89 ohms.
E to the I 1.
E to the I, in Euler forgive me format, 1 degree.
0.0.
How much? .2. Milliamps. You said 10 to minus 3, so I'll make that milliamps. And what's the phase?
Negative 1
Of
degree.
my total is minus 1 degree. And what is the RMS? Whoopsie.
It's 2.8 milliamps over root 2. Wait,
0 minus
And it's how much?
2.
So 2 milliamps would have been easier to do as a first step, because in fact, 10 volts over 5 kilo ohms, 10 over 5 is 2, and 1 over kilo is milli, 2 milliamps. Okay, makes sense? So this circuit is nearly just the resistor. The inductor is hardly making its presence felt. Yeah? From that total current. Yeah, the voltage on the resistor.
I didn't see that. Not really. I really wish I was over.
VR is?
IR. ID.
Format?
E to the I phi.
Yeah, C e to the I phi. Now, just for fun, I'm going to do this first as RMS. Just to be different. Okay? In that case, the RMS current is 2 milliamps.
Right.
e to the I minus 1 degrees. And the Z of the resistor is
5,000. Rounding it?
to the level at which we have now rounded off how much voltage goes on the resistor.
And
10.
Oh, wait, 10. Got the million.
And the phase of the voltage on the resistor is
negative 1 degree.
and the peak on the resistor is 10 times square root of 2. Square root of 2 is 1.414. Times 10 is 14.14. Okay? And that, in fact, to the level that we've rounded off is all of it. It should really be something like 9.9996 or some such thing, but really you basically got it all on the resistor at this point. You got it all on the resistor. And in a minute we'll talk about why this is not a good exam problem, but it is a good review problem. Last thing to be calculated is voltage on the inductor. A plus IB or C e to the I format? Yeah, C e to the I5, so I'm going to do this one in RMS first also, just because the numbers are round. So that's 2 milliamps, e to the minus I times 1 degree, and the Z of an inductor is omega L e to the what? I 90 degrees in this, what we're calling Euler forgive me format. People like degrees. Okay, omega L, we knew what that was. $94 point something? So how much voltage on the inductor?
188.4.
1.18.
Phase of the voltage on the inductor is? And the peak value? Now, we've used terms like high pass and low pass, right? In this circuit, if you're with the inductor, what kind of a circuit is it? High pass. If you're with the resistor, what is it? Low pass. Who got the voltage? The resistor. Why? Because the frequency was low. Compared to what? We've said high pass when we said low pass. We've only said high and low. We never said high and low compared to what? Tell me philosophically, where is the what point that you compare with high and low? This circuit is not resonant because it doesn't have a C in it. It only has an L. So what would I compare to find the frequency that I should compare this one to?
On the power supply?
No. Something about impedances, yeah. Where you get the two of them equal. Okay? There exists a frequency such that where omega L would be the same as R. That's the frequency that defines the boundary between high pass and low pass. Because this is the 50-50 point. When omega L is the same as R, the ohms of the resistor and the ohms of the inductor are the same, and so it splits up 50-50. Frequencies higher than this go to the inductor, frequencies lower than this go to the resistor. Let's calculate for our values what F that would be. It was 3 millihenries, is that right? So what frequency do I get from this calculation?
2.5 times 10 to the fifth.
How many of you are audiophiles? One. Okay. Have you ever heard the... Well, do you know what a biaxial, triaxial speakers? Sometimes you have speakers with more than one driver in them. Okay. In that case, I'm actually blanking on the correct term. What's the term for a speaker that has a tweeter, a mid-range, and a woofer built in one speaker? It's try something. I'm blanking on the term. I don't think it's triaxial. It's try something. But anyhow, in such a speaker, people will talk about crossover frequencies, because the lowest frequencies go to the woofer, the highest frequencies go to the tweeter, and in between goes to the mid-range. And in order to get a speaker with uniform response, you have to adjust the crossover frequencies that go to each of the three speakers. And you do that with filter circuits. This frequency would be the crossover frequency. Higher than this is considered a high frequency. Lower than this is considered a low frequency for this filter. In our case, what did we send in with 5 kilohertz? Higher than this or lower than this? Lower. So, the resistor got it all. So if you were a circuit in parallel with the resistor, you got it. All of it. Because you were on one side of a low pass. If, on the other hand, you were a circuit in parallel with the inductor, you got less than a couple tenths of a volt. Because you